solve a few questions, and I'll give you time to do a similar question. Right? Here we have 3x to the negative 2 times y to the third, and x cubed times y squared. The question says to simplify this and write into a form that does not have negative exponents. We'll talk about this later. Let's just try to simplify for now. What I want to do is you can rewrite this thing 3 times, because that's the meaning of third power, right? If you have anything to the third power, that means you're multiplying this to itself 3 times. So I'm writing this 3 times. Divided by this, you write twice. Okay, and then we are going to use the property that multiplication can be swapped around. You know, 3 times 2 times 5 is same as 2 times 3 times 5. You can swap the 2 and 3 when it comes to multiplication, right? In the same way, I can change places and see that 3 is here, 3 is here, and 3 is here. So you have 3 multiplied 3 times. And then I also have x to the negative 2 multiplied 3 times. And I see y. So y is multiplied to itself 3 times. Over x cubed is multiplied twice. And y is multiplied twice. And after you do this, you see that in general, you can just skip this process of writing down and say, oh, if you have a number here, that is just going to be applied to each of these products, right? So if you have cubed, that means 3 will get cubed, x negative 2 will be getting cubed, y should be cubed, x cubed will be cubed, y will be squared. No, x cubed will be squared and y will be squared. Okay, so you can skip this process and then just go from here to there. Now let me ask, what is x to the negative to the third? What do? You multiply. If you have exponents here and then inside the parentheses, they multiply, right? So we're going to write down negative 2 times 3, which is negative 6. And then you have 3 times 2, which is x to the 6th, y squared. And then 3 cubed is 3 times 3 times 3, which is 27. And then now I want you to look at this and see that you can pair these two, and you can also pair these two. If you have the same base and you're dividing, what do you do with exponents? You subtract, right? So you can subtract negative 6 minus 6. So negative 6 minus 6. Same deal here. It's y, 3 minus 2. And then that gives you 27x to the negative 12, y to the first power, and we don't write down first power, it's just that. Okay, now, this seems to be simplified as much as possible, but what do you not like about this as the answer? The question says, do not have negative exponents, right? So, I see that there's a negative exponent, and what can we do with it? Put it into a fraction. So what we learned last time is that if you have a negative exponent, so the rule that we talked about last time was that if you have x to negative n, that's same as 1 over x to the n, right? So the negative exponent actually makes something go down to the basement, right? So and you can bring something that's in the basement above ground by negating the exponent. Yes? Uh, no, you're subtracting. If they were both x to the sixth, then they cancel out. Yeah, right now you can't cancel them. So what you're probably confusing is like if you have x to the negative sixth times x to the sixth, then because this is 1 over x to the sixth power, then if you have something above ground and the basement that they're equal, you can cancel them out. Okay? In that case, these two cancel out to give you 1. But if you're dividing, it doesn't cancel. In fact, it becomes bigger, right? The exponent becomes bigger. Okay. But anyways, coming back, using this property, we can send this x to the basement. And if you do that, this minus will turn into positive, right? So you have 27 times y, still above ground. These guys are still above ground, but x to the negative 12 is now sent to the basement, is down here, but with a positive exponent. Okay, so that's basically the idea. And I'm trying to solve another question because I want to demonstrate that you don't have to go through all the calculations. You can skip a lot by doing the following. So if you have 2 to the fourth power, what's 2 times 2 times 2 times 2? 16, right? So 2 to the fourth power would be 16. And anytime you don't have an exponent, you can think of it to have 1 as the first power. And what you do is, because you have a number outside the parentheses and you have a number inside, 4 times 1 is what you get. So you get x to the fourth. And then here, 4 times negative 2 gives you y to the negative eighth, right? And then you have 3 times 5, which is 15th power. Negative 2 times 5, which is negative 10th power. Okay? So over here, I had to write out all these powers explicitly because I haven't told you the formula, which is that you can bring this into each one of them. But now that we know that's true, we don't have to go through all of that steps and just right away take that number, whatever that is, you just multiply to each one of the exponents, right? So here you have 2 to the first power to the fourth power, which means 2 to the fourth power, but 2 to the fourth power is 16. And all of these I just multiplied. Okay, now this time I only see this guy here, right, as something can be computed. These I can't divide because their bases are different. So you can't put this into a single thing. Their bases are different. These I can do something about it. They have the same base. So what do? Subtract. So we have 4 minus 15 times y to the negative eighth, z to the negative 10th, which I can't do anything about, right? Okay. So let me continue calculation over here. Okay, this is going to be equal to 16 times x to the 4 minus 15 is negative 11 times y to the negative 8, z to the negative 10. And anything that's by itself is considered above ground, okay? This guy here is in the basement. These are all above grounds. When you multiply numbers, things above ground multiply together, things in the basement multiply together. So what you get as a fraction is you have 16 times x to the negative 11, y to the negative 8, over z to the negative 10, because this is the only guy that's in the basement, right? Okay. Now we have a whole lot of numbers to change, a whole lot of negative exponents to change, right? All these negative 11, negative 8, negative 10 has to change. And how do you make it positive? X to negative 11, where do you send this? Downstairs to the basement. Okay. y to the negative 8, downstairs too. Now, what's in the basement, if it has a negative power, you can also make it positive by bringing it upstairs, okay, over ground. So you have 16 times z to the 10th power. This was in the basement. Now it went above ground with a positive exponent, and then you have x to the negative 11, no, positive 11, and y to the 8th power. And now all of these exponents are positive. It's as simplified as you can do. There's nothing more to simplify, so that's the answer to part B. Yes?
Can you just go over one more time why the 16 doesn't also work?
16 has positive power, right? 16 is the first power, right? Yeah, so that it stays above ground.
It's only the negative ones.
Yeah, if there's a negative power, then you move it to the downstairs, right? Okay. Anytime you don't see an exponent, that means it's power of 1, okay? It's power of 1. And we decided that if you have any number, that gets multiplied to each of these exponents. Is that okay? Now, one word of warning, that's only true if this is a multiplication, and it is, right? Yeah. If it's addition, that's no longer true. That becomes a lot harder thing to think about, okay? So, but today we're only going multiplication, okay? When it's a multiplication, this you just multiply to each one of them, right? Okay, so you get 3 to the 1 times negative 3 is? Negative 3. 2 times negative 3 is? So you have x to the negative 6. 1 times negative 3 is? Negative 3. And then 1 times negative 4? Negative 4. 1 times negative 4? Negative 4. 2 times negative 4? Negative 8. Okay? So that's what you get. And again, we have just one part that we can simplify. This is same base, and you're dividing. If you're dividing with same base, what do? Subtract. So this is going to be equal to 3 to the negative 3 over 2 to the negative 4 times x to the negative 6 minus what? Minus negative 4. Okay? So you're subtracting a negative 4. That's different than subtracting 4. You know the difference between subtracting a 4 and subtracting a negative 4. They're completely opposite stuff, right? You know that? Okay. So you need to write down subtract negative 4, and then the other parts we can't do anything about it, so just leave it like that. And then what is negative 6 minus negative 4? That's same as negative 6 plus 4, right? Negative negative becomes positive. Negative 6 plus 4 is negative 2, right? So you have 3 to the negative 3 over 2 to the negative 4, x to the negative 2, y to the negative 3 over z to the negative 8. Oh, okay. So a whole lot of negative exponents. We have to send them to the basement or overground. Like we have to, yeah, send them. Yeah. So let's do that. So this guy should go downstairs, 3 to the 3rd. This should move upstairs, 2 to the 4th. This guy should go downstairs. That one also downstairs, and this should go upstairs, just like that, okay? And then you just multiply the guys on the upstairs and the guys in the downstairs. So you have 2 to the 4th times z to the 8th over 3 to the 3rd, x squared y to the 3rd. Oh, but then 2 to the 4th is something you can calculate, right? So you should actually do it. What's 2 times 2 times 2 times 2? 16. What's 3 times 3 times 3? 27. X squared y cubed. All right? So that's what you have.